Okay, welcome. Thanks for joining this third in the series of Agentic DevOps. Some housekeeping, just to kind of know that the Q&A window is actioned, but the mics and cameras are disabled. Now, with the volume of people that we've got on this call, we might struggle to reply to every question. We will be publishing answers to any questions that are published on the website afterwards. Also, take note of this email address, ukdevsc. If there's any questions that you've got that we don't actually answer in the session, then please just kind of reach out. So yeah, that email address, the developer SCs are all monitoring that, so make use of it. Okay, so we talk about digital transformation being fundamental for business success, but it's software innovation that's at the core of digital transformation, and for that you need application development. The catalyst for application development is software engineers, and successful companies will be those that empower software engineers with the best tools and platforms to achieve more. And DevOps is this engine that drives innovation, and you can deliver software faster and higher quality that was possible with previous methodologies. Now we talk about the inner loop, and that's where kind of developers do their development, they test, they test, and they just repeat. And then there's the outer loop. That's where we kind of like deploy the apps, we kind of monitor the health of the apps, and then we drive the next iteration. So GitHub Developer Platform supports requirements in both the inner and outer loop, but increasingly we see it as the AI-powered developer platform. Now, up to the end of last year, we kind of think about being at wave one of AI-assisted development. So that was really kind of plugins into your developer tools. And if you was an experienced developer, it was kind of reducing your think time, reducing your keystrokes. And then if you was a less experienced developer, it was acting as this kind of learning assistant. And it was just speeding up coding, debugging, testing. So developers typically don't like writing unit tests, could just kind of accelerate and find kind of edge cases. Also super good at writing really high quality documentation. And then the other kind of workload it was really good at was kind of removing technical debt. So, technical debt is the kind of enemy of innovation, because if you're spending time firefighting, you're not kind of doing things that are innovative. We're kind of now moving on to wave two, and that is kind of embedding agents in the complete software lifecycle. So we're accelerating and improving every phase of software delivery. So we can do things like, if we raise an issue, we can assign it to an agent. If we write some code, previously we would have given it to a colleague to review it. We can now assign it an agent to do a code review. If we're creating a pull request and we really want to understand what's in that pull request, assign it to an agent. If we're doing running code security scanning and we find an issue, let's assign it to an agent to fix it. We've now got agents that can actually monitor the health of your estate, your applications that are running. And if they find things are malfunctioning, they can raise an incident in GitHub, and then we can have an agent that wakes up and triages that issue. And ideally, it's going to identify the issues and self-heal before we need to actually call an agent. Sorry, we need to call a colleague in to actually look at that issue. So this slide kind of shows the role of a wave two frontier software developer. So AI is now improving software productivity and quality by such a magnitude that every software engineer needs to be on board, and they're going to be replaced by others that are. Companies that are not on board will be quickly outpaced by competitors that are on board. So GitHub provides this kind of agentic layer around the complete software lifecycle. So the role of the software engineer will be managing a fleet of AI-powered agents, accelerating every stage of the software lifecycle. And these agents, they will be specialists. So we might have like the Kubernetes specialist agent, or the Bicep agent, or the Terraform agent, the web testing expert, the integration expert. So the best software engineers will be those that have a comprehensive set of teammates and know how to ground them to work to their best. So grounding those agents means connecting out to things like these agent primitives. So things like instructions and skills and MCP services. MCP services provide the knowledge and knowledge bases and tools, and also using the right model. So different models, some models are kind of in-depth thinking, others are kind of fast. So using the right models for whatever that agent best needs. So this kind of shows the SDLC with the different pillars, and it's got the GitHub products on there, and just adding in some Microsoft products in here. So, the code, we've got the developer tools, we've got the testing tools, we've got the security tools, and we've got the kind of the PaaS services, and then the observability tooling. What we're going to do is have an agentic layer provided by GitHub that runs above the SDLC, and we'll have a number of agents. And I've just provided a few agents like the coding agent, the review agent, etc. But in time, there'll be more and more agents running in this agentic layer. We will also have partner agents, so things from Codex or Claude. We can have custom agents. So this is where you can write your own agents that adapt to a particular persona. And then what we kind of announced on Friday is these agentic workflows. So this is all about having workflows that can kind of self-heal your DevOps environment. So we're going to have this kind of AI tooling, and it's going to boost productivity across the whole software lifecycle and can add value and impact to many, many different roles and personas. So there's lots of examples here, but just taking a few. So for example, DevOps infrastructure teams can use Copilot to quickly scaffold and validate infrastructure as code and create automated workflows. Just turn my phone off. Data scientists, data engineers, they can use Copilot to speed up creating and maintaining data pipelines and notebooks, and they can deliver insights quicker. Architects can use Copilot to get guidance from proven frameworks, accelerate the design, quickly turn intent into technical blueprints. QA teams can use Copilot to rapidly build robust test cases, spot hidden risks, and get up to speed with unfamiliar code. And then product managers could use Copilot to bridge the gaps between ideas and implementation so they can make their specs clearer and complete. And so that speeds up time to value. So I'm sharing a link here. So if you remember the graphic where I talked about the Wave 2 developer, and I said on the right-hand side, there was those things that a software engineer needs to get familiar with to be really able to tune or ground those agents in an optimal way. These are the kind of the 6 primitives that you need to get really familiar with. I recommend you kind of look at that article. It's written by a Microsoft colleague, and I think it's a great document that goes into each one of these, how to get the most out of the different areas. Also refer you to this site, Awesome Copilot. So this has got some great examples of custom agents. So this is what a custom agent looks like. So it's just Markdown. In this particular example, it's a pretty simple one. So it's specifying MCP tools, it's applying the model to use, and then it's applying handoffs where you can kind of call other sub-agents. But these could be more complicated. They can refer to other skills, they can refer to validation checkpoints and gates whether they should proceed. How do you invoke a custom agent? Well, there's 2 ways. So the left hand is showing kind of Visual Studio. You're maybe familiar with the different modes like agent, ask, edit, plan. If you've got a custom agent configured, it will actually appear in this list. And then if you're using it in github.com and you want to assign an agent to an issue, what you actually do is in the list is select the custom agent. So there's an example of a number of agents that's available to the user. So I touched on in one of the graphics earlier, agentic workflows. This was announced on Friday and just dropped. And the idea is, actions in the past, you had to put very kind of precise instructions. What you can now do with agentic workflows is just define, and as in the example on the right, just define in English, in natural language, what you actually want the workflow to do. And some examples, self-healing DevOps or kind of triaging issues or PRs or just keeping your documentation up to date and a high quality. Okay, I'm going to switch now to some demos. Again, just if you've got any questions, that's the email to kind of reach out to. Okay, so what I've got here is a game that I've written, and hopefully you can hear some music in the background. And the idea is that when I drop these balls, if you get two of the same type, it fires a sound. So I use Copilot here to greatly increase writing this. Things like the physics engine, the partition effects. Yeah, I did this much faster than I could if I was just writing it. But part of the sound, what I knew that the browser's got a web audio API, but I didn't know too much about it. But I also thought that there was a number of functions that I needed on top. For example, like loading up the music in advance, and then playing on demand. That's pretty useful if I could write that into my own library. Things like transitioning from one music sound to another, by changing the volume of one, increasing the volume of the other, have a transition effect. Again, I just thought it was reusable. So what I wanted to do was create an audio library that talks to the web audio library, but would just give me a kind of some middleware, some reusable functions that I could use time and time again. So if I wrote another game, I've got my audio library that I could use. So the way I did this was I just created a blank GitHub repo. So there's nothing in here other than the license and the README file. And what I did was I created an issue, and I just listed the functions that I want in this audio library. And there's really two parts. I wanted the audio library, but I also wanted a test harness around it. So I said here, audio library, I want a test harness, and I want the library itself. I've also said I want some detailed documentation on how this library is going to work. And then for each thing, I kind of listed some functionality. So for the audio library, I said I want sound effects that are kind of fast, fire and forget, but I want music that's longer. I want to be able to load it up, preload this music, so there's no kind of delay once we get going. I want support from volume, but I want to change the volume of the master volume and the sound effects independently. I need to support these codecs. So, there's about 15 items in here. And likewise for my test page, I've kind of listed 15 items in here. So there's about 30, maybe 35 items that I wanted to do, plus create detailed documentation. Now, how long would it take me to write this if I was doing this myself? I don't know. Maybe there's a day for me to learn the audio, the web audio library. Writing the documentation itself, there's probably a day's worth of work in there. It probably would take me about a week to do this. What I'm going to show you, this was actually done by AI in 6 minutes. And the way we do this, we assign it. In the past, you might assign this to a developer. What we can actually do is assign it to Copilot. Or actually now we've got some other agents. I could assign it to Claude or Codex. So if I assign it to, say, Claude, in the same way that you might have assigned it to a developer, we can now assign it to AI. And Claude has woken up and it started to work on it. Now, this takes, as I said, it takes 6 minutes. So I've got one that's a kind of clone of that repo, and it's here. And I've already assigned it to Claude. If I look here at the detailed log, So this is where I can actually see, if I go to the top, it's taken 6 minutes to actually go create my audio library, create my test harness, and write all the documentation. Also spot that it created MCP playwright server. So it's actually going to test the code. It's not going to just throw a load of code back to me and hope it works. It's going to have high level of confidence that it actually does what I need it to do. If I just go back to the pull request, the other thing that you can do is once it's written, what you would have typically done is assign that to a colleague to actually go and review the code it's created. What I actually did here was I assigned it to Copilot to actually do a code review. So I've got Claude writing the code and I've got Copilot checking the code. And Copilot actually did come up with a few comments. So it's like here, and I could, it's made some suggestions and I could read that. And if I think Copilot is right, I could then give it to Copilot to then go and solve what it's suggesting. If I flip over here, this is actually what it's created. So it's in a branch, so I'm showing the branch. There's the test harness. There's the actual library that it's created, and there's the documentation file. So if I click on the documentation file, you can. That's good. It's just. So here's the documentation it's created, and how to install the library, quick start. So if I want to have a quick, minimal example to get it going, this is what I need to do. Just basically pull in the library, instantiate it, initialize it, load my music, and then I can play it. So that's a quick start, but there's detailed documentation here. This alone, I think, would have taken me half a day to write, certainly to get this kind of quality. And then just to show you, I've pulled that repo down to here, and if I actually, that's what it's created, and then if I run it, that's the test harness that it's created. So I can initialize the library. I can select music track 1, music track 2. I can play music 1. Hopefully you're hearing that. I did share sound on my when I shared the screen. Hopefully you're hearing it. I can do a smooth transition from one to another. Okay. Let's just close some stuff down. Okay, so that's coding agent, that's review agent. Let's show you, let's look at some custom agents. Okay, what I've got here is a repo called accessibility. So the custom agent I'm going to show you is going to do a accessibility validation on some web applications. And if I show you the actual agent itself, so it's stored in the repo at this location, and it's kind of all the information here, how the agent should behave to do a WCAG accessibility audit on an application. The way that you can use that agent is whenever you're assigning work to the agent, I showed you earlier, I could assign it to Claude or Copilot. What I can actually do is assign it to my custom agent. Let me show you the application we're going to test. So I've got an API that just generates random colors. I've got a screen here that I want to do the check against. This does just a form. It's going to configure the API. And then this screen here actually calls the APIs, gets the random color, and just lights up the circle in the color that comes back. Now there's a nice navigation screen, but I suspect the from an accessibility point of view, it's not great. So that's the application we're going to test. The way that we do this is I've created an issue and I've said in here, inspect these web pages and write me a report. And I want you to validate to WCAG 2.1 level AA. For each issue, I want to know whether it's critical, important, or nice to have and explain why. And I want a checkpoint list at the end and then write the report to that. What I do is I just assign it to the agent, and what it does is it creates a pull request to actually go and do the work. If I look here at the session, I can get a detailed view of an audit of everything it's done. So it's done that in 8 minutes. And if I switch to here, this is the actual plan that it created. And here's my output. So this is the output. I've already run this in earlier, and it's identified the critical issues. As I said, I thought it would find some issues with the navigation sidebar. And it's like the important issues, and then the nice to have. And then at the bottom, if you remember, I asked for a checklist, and it's done that into the documentation. So that's my accessibility custom agent. Let's just close this down. I'm going to show you another one. So this is going to be a QA checker agent. It's going to create me some regression tests. Now, what I've got is an API that just gives you kind of pins on a map. And I've created an issue here. I've said, create me a website, show me a map of the UK and plot the pins on the map. And that's what it looks like. So Copilot in a few minutes creating me a website like that. Okay, so what I want to do is actually write some tests using Playwright to validate that application such that if I ever make any changes, I can rerun my regression tests. All I did was, actually, let me show you once before. Here's the agent. This is the custom agent. If I want to invoke an agent, the Playwright tester one, all I do is I assign it to the custom agent. And then what I've done in my regression test issue, I said, create me some Playwright tests to test the application, identify that. So what it's going to do is identify all the user flows through that application. That alone could take a certain amount of time. Create me some test scripts and then create me a checklist for reviewers. So I've assigned it to Copilot. Copilot's gone and created me. So this is the output. It's running at I'm looking in the branch. It's created me the tests and it's created me the documentation. So if I look at the user flows, it's given me flow 1, flow 2, flow 3, etc. It's given me detailed documentation how to run these tests. So if I want to run these tests, this is what I need to do. So if I let's just go. And the instructions was npm test. So this is now running the Playwright tests and it fires up an instance. So it's instance of the browser running in the background, and it's doing 8 tests at a time. So it's done 8 tests. It's done the next 8 tests. I'm waiting around here because it will actually create me a report so we can actually see the results of these tests. So the last 4 tests. Okay, and then it's giving me this output here. And this is the output that it's created. So each test, I get a detail what it's actually done. And point being is if I change my application, I can rerun my regression test and make sure nothing has kind of broken. Okay, next. Let's have a look at another custom agent. This one here. So this custom agent is a technical content evaluator agent. And I'll show you the agent. This is going to basically look at a technical document and score it based on all the criteria. Sorry, no, this is the agent. This is the agent that's going to do, these are all the things that it needs to look for to score how good the document is. And the document I'm going to actually get it to test is the documentation that was created as part of that audio library that we saw in the first demo. So again, if I want to use that agent, I just specify it here. And all I've done is I've created an issue. I said, I've got this library here. It's located at this location here. I want to evaluate it and then put the output in the issue. Sorry, in the repo. I want to know how can it be improved and then provide me a checklist of actions. So I've assigned it to an agent. It's created a pull request. It's gone and done the work based on that agent. And then if I flip over, so there's the pull request. This is the output. So if I look at the evaluation summary, it's looked at that document and given it a grade of B plus, 87%. And then it's kind of identified what are the gaps. What do I need to do to improve my technical document to get it up to a grade A? And then if I look at this, the evaluation report, it's now detailed documentation on what I need to do to improve that document. And then there's a checklist. So I can actually check and make sure I do all the things that it suggests I need to do to improve that document. Okay, one more example. We touched on agentic workflows. What I've got here is a repo. It's just got a .NET application in here. But if we look at the actions, sorry, if we look at the actions, what I've got here is an action. If you're familiar with actions, you normally see very precise set of instructions what to do. All I've done in here is kind of in English, in language, I'm asking for a daily status report of the repo. And I've just put in here in kind of natural language what I expect to see in that report. What actually happens is GitHub will transpile that document in a natural language into an actual agentic workflow. So if you're familiar with actions, this probably looks more familiar. And what it's doing, it's firing up the GitHub Copilot SDK in the background to actually do the work. And so this is what's happening. So in that report, I said to run this daily. So actually, if I go to issues, this is what it's created. So on the 17th, which is today, it's basically generated this report and said, look, you've got one PR open. It's been open 4 days. There's a draft PR, etc. Okay, we are at time. It's past. Just once again, hope that was useful. Any questions, reach out to UK Dev SE. Thank you. See you soon.